Hello everyone, welcome to Unlock Maths. Today we are going to solve particular integral when we have x is equals to x raised to m into v. Yes, we know that here v is a sin ax or cos of ax and m is here positive integer. In last lecture we have seen how to proceed for this type of x when we have v is equals to sin ax and cos of ax. Yes, we know that when we have v is equals to cos of ax, we have pi is equals to real part of this 1 upon f of d into x raised to m e raised to iax, right? And when we have v is equals to sin ax, we have the imaginary part of this operation, right? So now let's proceed for the example. So here we have to find pi of this differential equation. So we will write down formula for pi and we will put these values of f of d and x here. So here we have, yes, now here we have this x as a x square into cos of x, right? So that, yes, how to proceed for finding this pi here? Yes, here we have to write down this real part of this operation, right? Yes, since here we have cos x is the real part of this e raised to ix. So yes, here we have to find the real part of this operation, right? So first here we will find this, then collecting real part of this we will get required pi. So yes, first we will find out this operation here. Yes, how to solve this operation here? We know that we have to proceed by this case here, x raised to m into e raised to ax, right? What we have to do? Yes, here we have to take this e raised to ax, this is outside this operation, and at the same time we have to replace this d by d plus a, right? So yes, here we can check that here we have this is as the square of this one, d square plus 1 its square, right? Yes, why we have write down this is as here? Because here we have fourth power of this d, and when we replace this d by d plus a, we have to take its fourth expansion. So yes, so to avoid that calculation, we have write down this f of d as this one here. So yes, now we will replace this d by d plus a, and a is here, this coefficient of this x here. So here we have this is, yes, a is here I. Okay, so yes, we will take this is e raised to ix, this is outside, and we will replace this d by d plus a here, remaining x square. Yes, first we have write down this expression as the square of this is, and we have taken e raised to ix, this is outside this operation, and we have replaced this d by d plus a, right? So yes, so first we will simplify this expression here. So here we have square of this one. Now here this is I square, this is as a minus 1, so this and this get cancelled. So yes, on simplification we will get here this d square twice id, and this is its square, right? So now yes, we will simplify this square here, so that here we have this is, so yes, here we have taken the square of this term, so that we got this is here. Yes, now yes, now this 1 upon f of d we have to operate on this x square. Yes, so yes, what we have to do here, we have to express this f of d as a 1 plus phi of d. Yes, and how to do this is here, we have to take this is lowest degree term, this is outside, so that here we have yes, when we take this is 4d square, yes, we will take minus 4d square, so that here we will have 1 plus, this is here remaining, so yes, this is here we have minus, so here we will have this is 1 minus, now on simplification we will get this is here d square by 4, and this is here again, here we have this 4 and d square get cancelled, so here we will have this is id, right? This is here we have x square. Yes, we have taken this is 4d square. Yes, we have taken here 4d square, this is outside, so that we can express this f of d as a 1 plus phi of d. Okay, and on simplification we got this term. So yes, here we got this 1 minus phi of d, this term, and now here we have to take this 1 minus phi of d in numerator, and that is with negative index. So on simplification here we have yes, now here we have taken this 1 minus phi of d, this is in numerator. Now we have to expand this is here by using binomial expansion, and we know what is its expansion. Yes, when we have 1 minus x raised to minus 1, here we have to take 1 plus x square plus x cube and so on, right? So yes, we have to expand this is here. So yes, here we have write down this expansion up to d square. Yes, because when we operate term of d cube and higher than of that d cube on this x square, we get 0, right? So that here we have write down term up to d square. So now we have to simplify this is here, and we have to operate this derivative terms on this x square. So yes, first we will simplify this is yes, on expansion, yes, we will write down the term of d square. So here we will have yes, here we have to avoid the term of d cube d raised to 4 and higher than that. Yes, because here we have to follow this relation here. So now yes, we will apply this derivative term on this x square. Yes, so yes, on simplification we get here this is x square, then we have so yes, now double derivative of this x square, so this is here 2, this is first derivative of this x square, so here we have this is twice x, and again this is here double derivative, so this is here 2. So yes, on simplification, so yes, on simplification here we have this expression. Now here we have to apply 1 upon d square on this expression. Yes, so we know what is this 1 upon d, this is the integration with respect to x, and d square, this will be double integration. So yes, we will apply this is 1 by 1 here. So first integration, by taking first integration, here we have yes, here we have taken first integration. Now again by taking integration, here we will have this is x4, this is by 12, and this is x cube by 3, and this is 3 by 2, x square by 2. Yes. So yes, here we have find the value of this expression, right? Now we have to find real part of this expression so that we will get required pi. So yes, we will write down pi is equals to real part of, yes, this expression. Yes, for finding real part of this expression, what we have to do, we have to write down this e raised to ix. This is cos x plus I times sin x. Yes, we need the real part of this expression, right? That means we need the term which is free from I, right? So yes, we will write down. So first we will multiply cos x to the term which is free from I. Yes, so here we have, this is x raised to 4 here, right? Yes, then cos x to the term which contains I. Next, same here, I sin x to the term which is free from I, and the term which contains I here. Yes. Now we need the term which is free from I. So yes, here we can check that here this term is free from I, and again when we simplified, this term is free from I, because when we have this is I into I, that is I square, and this is minus 1. So yes, so we will collect these terms. We will write down these terms closer to each other, and term which contains I. So here we have, so yes, here we have find term which is free from I, and this is with I, right? So that means this is the term which is free from I. This is the real part of this expression. So yes, we will write down the real part of this operation. So here we have, yes, so we got this term which is free from I, and this is the real part. We find real part of this expression, and this is the required pi. If we want, we can do the simplification here. So yes, here we have done the simplification of this expression. So this is the required pi. Yes. So yes, how we have proceed for this given differential equation? Yes, when we have this type of x, we have write down pi as a real part of this expression, right? And we have simplified this expression by using earlier cases. Then we have separate real part of this expression so that we got this required pi. So yes, that's it for now. See you in the next video. Thank you. Keep watching.